So just let me know when we start.
It's fine. Yeah, you're recording. Yeah, it'll be fine.
Well, we might want to. Here, let's close this door so that I won't close it all the way, but there are people out there that might be annoyed by me talking loudly. Yeah. Okay. Do you want to introduce? Or
All right, yeah. Hello, everyone. So I'm John. Most of you know me because a lot of you are repeat visitors to our meetup. But I started this meetup. I run it with Tony over here. I run this little co-working space, and I work for a company called Q Doctor. And I actually hired Colin in the past few months to join me, so he works out of here as well. So he's going to be doing a nice little presentation tonight. So I'll let you go too.
I like that you're both rocking the Q Doctor beard.
Yes. That's a requirement.
Yeah. I didn't have a beard when I started, and I just had to grow it, right?
In like a couple days.
Yeah.
Instantly.
It just happens. So I created this fictitious code base. And scattered throughout the code base, there's some sample code I'm going to show you. The first bit of code is I have this piece of code here. Apparently, at some point in the code base, we want to, when it's a leap year, we want to have a week earlier. We have a function that we actually want a week earlier. And that seems a bit weird, but you know, business requirements are weird sometimes. But the users got a little confused by this, and we ended up having to create another function to provide a bit of text on the front end if it was a leap year, tell people that it was crazy or sane. Then some project managers got involved, and they were like, "Oh, you know what? On that leap year, I can actually get an extra day for each resource on the project. So I want to add a day in for each resource." They're being really clever and project managery. And then some other person was like, "Oh, well, when I have an extra day, I want to save it for later. I'm just going to put it in the bank and not use that day." That's the way dates work, right? So anyway, the weirdness of this code base, let's not focus on that. The problem is that I solved the whole, the singularity has passed, and I've survived to the year 2100, and there's a bug. All right? So there's a bug. It has nothing to do with the weirdness of the code base. It's the fact that the year 2100 is not a leap year. Now, I don't want to talk about date stuff. I want to focus on sort of the context. This is like a more accurate way of determining if it's a leap year or not. But the thing I did, you notice I put it into a function. And the reason I did that was because I don't want to change all four of these places more than once. So I took all of these different places that were broken, and I extracted them into functions, into a single function, so that if there was another problem with leap years, like I got it wrong again, I would only have to fix it in this one place. But then I was like, I don't want to run into more bugs. Like, I could have prevented this bug if I had foreseen it. And so I want to start working on figuring out how I can prevent future bugs with this piece of code. So one of the things that I want to do is I see all of these numbers here, and I'm like, oh crap. These are like hard-coded numbers in my code base. And people say that's bad, you should extract them into constants. So I did that. I extracted those numbers into constants, so now we know what the numbers mean. It's really obvious what they mean because there's these long verbose words saying what these numbers mean. And then I looked at it again, and I was like, oh, you know what? This is a common concept. We're figuring out if it's divisible here. So we're doing this modular arithmetic, but really we just want to know if it's divisible by some value. So I created a function called divisible. And then I looked at it again, and I was like, oh, this is starting to get kind of big. I should extract this into a class because the single responsibility principle says that you should have one responsibility for your classes, and wherever this is in the code base, it's too much. It's too much. It's just too complicated. So I extracted it into this class, and I was like, this is so much better. I feel so much better having extracted it into a class. But I don't really know what's going on here. I don't know why I'm figuring out if these things are divisible. So, sorry, I got ahead of myself. Actually, this time I was like, this divisible method, like I want it to be, I don't want other people to use this divisible method. It's just a utility function for this class, so let's make it private. And then once I made it private, like, oh, I'm safe now. Nobody else is gonna use this divisible method. I don't have to worry about it being used in weird ways later on. And then I was like, oh, now I don't really know what these things mean, so I'm gonna extract them into more descriptive methods. Now hold on. Is this really better than this? I mean, seriously, let's look at this. Do you know what's going on here if you read this? Is this more descriptive? Can you understand this better than this? I don't think so. Now, there was an important step of refactoring. There was the step that of like extracting it into a function. And that was important because you want things to be in a centralized place. Duplication is a good example of something that should be fixed most of the time. But all that other stuff I did, that was just like bullshit. I didn't need to do any of that. But if you talk to some people, they will look at this and say, look how descriptive it is. Look how it fixes all of these problems. It doesn't use hard-coded numbers. It's broken up into its own class. It has descriptive method names for this method here. Like, they'll look at this and they'll say, this is amazing. Follows all of the appropriate design principles. And other people will look at this and say, oh, that's so complicated. Why couldn't you just do this? Why can't you just have fixed this and like modified this in all these places? Because then you can see exactly what's happening. So the thing is, I'm not saying either of those camps are wrong. I think they just go too far. So this is something that a lot of people have had a lot of trouble accepting in software design. We want these rules. We want these things that when we say them, we want to have these like absolute statements that say, when this happens, you do this. And so instead of developing software being a creative act based on like intuition, it becomes a mechanical act based on rules. And we like that. We like that because it's clear cut when we've done the correct thing or not. But I'm here to tell you that in most of these cases, you want some middle ground. You don't want to like have this incredibly complex design that adheres to all of these design principles. But you also don't want to like completely abandon the design principles. You want something in the middle that is, and finding that middle ground is very challenging, and that's, I think, what separates really experienced developers from people who are, you can come on. That's what I think separates very experienced developers from people who have not been developing for as long, is having good intuition around when you need to apply these things. And I think that the most important lesson you can take from this is that you don't want rules, you want guidelines. You want guidelines of how to handle situations. So instead of like trying to predict all of the problems that could happen, this code here, this code tries to predict all of the problems that could happen and fix them before they happen. But I think that what you need to do if you start having these theoretical problems, if you want to fix them, you have to make them practical. You have to actually cause these problems to happen somehow if you want to fix them. So let's take a step back and look at the different ways that code can be changed, the reasons that we want to go in and change a code base. So one is just fixing bugs. Like, there's a bug, it has to be fixed, obviously. Another is you want to address an additional corner case. It could be exposed by a bug, it could be you just realize that there's another corner case. Then another is, and this is where it starts to get into fuzzier reasons, is a lot of people like to modify the code to make it easier to understand. And I'm not going to make any absolute statements, except for that one, in this presentation. Sometimes you do want to modify something for reusability, but some people use reusability as a reason to make modifications that are actually damaging to the code base. Another reason is maintainability. Same vein, you try to make something more maintainable that actually is harder to understand. That's it's all this balancing act. You don't want, and I'll go into more example around what I mean. Another reason to change is performance. The code's slow in this one place. We need to fix make it so that it can run faster. Reusability. I think that's a lot of what we were getting at with that big complicated code example, was people were trying to make it more reusable because they were breaking it up into these like constituent parts. That's another example of a reason to change code. And then aesthetics, like you think that this one way looks significantly better than another. Like, I like tabs better than spaces, for instance. That's an aesthetic reason. It's not actually it doesn't have a strong, compelling reason within like a problem that you're trying to solve, but it will make the code look better in some abstract way. So what I want to do is, these are all the reasons I just could think of that I'd want to change the code. And what I want to do is I want to talk about ways to make these things more practical. Because a lot of these sort of have theoretical problems. Like, maintainability can be a very theoretical problem. Like, example A is like that big, large, complicated piece of code versus that little small function. Some people say that the big, complicated piece of code is easier to maintain than the smaller one. Other people say the smaller one is easier to maintain than the more complicated one. I want to take these things that we're trying to do, and I want to try to provide examples of ways to make it less abstract and more practical. So the first thing I want to talk about is this notion of corner cases and bugs. So going back to where we were before, the concept of leap year, this doesn't fully represent the concept of a leap year. Now, you could just say, oh, I recognize that this that 2100 is not actually a leap year, but this code is going to say that it is. What I'd like to suggest to you is one guideline you should use is to make that failure happen. In this case, I use a test as an example. You want to create a test that can actually reproduce the problem that you're trying to solve. Not necessarily, we haven't necessarily seen this in the wild. Maybe we have, maybe it has become the year 2100 and everything's blowing up. But this makes the problem more practical. And this makes it so that when I make this change here, I'm actually solving a real problem as opposed to a theoretical problem. So that's an example of a way to make bugs and corner cases more practical than they were than the theoretical, like this might happen in the future. The next thing I want to talk about is, I'm sorry, I don't see the note there, hang on. Yeah, readability. So it's very tempting to say, oh, I want to switch this this piece of information here. I might not know what this piece of information means, and I, as a developer, feel it's important to communicate to other people what it means. And so I want to extract this into a function and call it leap year, and that will give me a better, give people a better sense of what the code is trying to do. Now, the thing is that as the author of the original piece of code, I'm a very poor predictor of what parts of the code will be clear or ambiguous. When I look at this piece of code right here, I don't actually need that extracted into a function to know that this is figuring out a leap year. Like, that's pretty clear. You don't need to extract that for readability, probably. I mean, you might want to extract it for maintainability if you have the same concept in multiple places. That's duplication. Fixing duplication is a great reason to, that's a practical problem. You have the same thing happening in many places, and you want to have it happen in one place, so the next time you add something, you don't have to retype the same information. But what I'm trying to say here is that it's not the first person who decides if a piece of code is readable. It's the second person looking at that piece of code. So in some ways, it's the second person's responsibility to make the code more readable as they're working with it. And that could be you. Now, this is a bit of a subtle point. You could be both the first and second person, because I've definitely written code and then come back 3 months later and had no idea what's going on there. And in that case, you have the feedback that's necessary, the practical problem that allows you to understand where the best improvements can live. Once again, it's this moving something from a theoretical, oh, people might not understand that this is trying to figure out if it's a leap year, to the practical, oh, I'm looking at this piece of code, I have no idea why I'm doing mod 4 equals 0. So I am going to figure it out and then create a method, create some form of communication to the next person who looks at the code. So then the next thing that I want to look at is duplication. And I talked about duplication briefly before, but we have this bit of duplication here, and that is and I want to extract it into this function here. Now, this is specifically to do with maintainability and reusability. So I want to. This is happening in two separate places here. This piece of logic, and I want it to be more maintainable. So I want to be able to take this piece of information and I'm talking in circles now. I'm sorry. The point is that you don't. So when I have this part of the code, just this part of the code, I don't have a practical reason to extract this into a separate function. It's not until this piece of code is introduced that I have a practical reason. Now the practical reason is I have some duplication. And this duplication is creating some amount of pain in both maintenance and reusability. And so this pain is the impetus for me solving this duplication. So once again, a practical concern that I'm feeling an amount of pain by having this duplication and I want to fix it. not just, I think that we might want to reuse this piece of logic here. One thing, a bit of an aside at this point, I have a lot of trigger words that, like, if I hear them, I immediately start to think, I think we may be over-designing this, and one of them is should. I've talked about this with Tony and John a bit before, but if I hear the word should, I immediately think, okay, so how can I move that from should to need? How do I make it so that it's no longer a theoretical problem? It's a practical problem that I actually can solve, as opposed to this might happen. Might is another good example of a word that if I hear it, I immediately start thinking that we're over-designing the product. So, next, I want to look at performance. So I mentioned performance before. You don't have to understand this code, it's just bubble sort. But for those of us who have taken computational theory, we know that bubble sort is big O of n squared. We know that quick sort is big O of n log n, which is significantly faster. The thing is that if I look at this, I don't necessarily need to think, oh, well, I have to fix this because it's suboptimal. The only reason that you'd want to fix a performance problem is if you have a performance problem. This is something that when you talk to people who do a lot of performance optimization, they say time and time again is, don't just fix things that look like they might be slow. Actually measure the performance of the code and find the places that are actually slow. And this is